Hello, lovely humans. Today is World Asteroid Day. This day is dedicated to raising awareness about the dangers of asteroid impacts and to explain what actions would be taken globally if a dangerous asteroid were ever headed towards Earth. I wasn't very knowledgeable about this topic at first, but while researching for this podcast, I found it absolutely fascinating. It's definitely something I want to keep learning more about in the future. So let's dive into the contents of this episode. Asteroids, or small planets, are rock fragments without an atmosphere that exists since the beginning of the solar system. However, they never grew large enough to be considered planets. They range in size from about 30 feet, 10 meters, roughly the size of a school bus or truck, to as large as 6 miles, 10,000 meters, which is approximately the height of Mount Everest. Asteroids can be classified into C, S, or M types according to their composition. C-type asteroids are the oldest in the solar system and are made of clay and rock and are dark in appearance. S-type asteroids are made of silicate materials and nickel iron. M-type asteroids are made mostly of metal, especially nickel and iron. The differences in what these type of asteroids are made of depend on how far from the sun they formed. Some asteroids got really hot after they formed, which caused them to partially melt. When this happened, the heavy iron sank to the center and lava, basalt, came up to the surface, just like it happens with volcanoes. Asteroids orbit the Sun and are found between Mars and Jupiter in a region called the asteroid belt. They usually have an orbit that is almost round and range in size from small rocks to over than a kilometer wide. They are located here because a long time ago Jupiter's gravity stopped planets from forming here and caused many objects to crash and break apart, creating the belt we can observe today. There are certain asteroids classified as Trojans because they share an orbit with the planet and don't crash into it. There is these two special spots called Lagrangian points, L4 and L5, where gravity keeps them stable. Jupiter has the most Trojans, but there are also some near Mars, Neptune, and even Earth. Finally, asteroids have orbits that come close to Earth. Some even cross Earth's path. For these reasons, they are closely tracked by scientists. These are called near-Earth asteroids. It's important to study asteroids because some have hit the Earth in the past, causing mass extinctions, for example, the dinosaurs, and caused major climate changes as well. For this reason, it is possible that some might hit the Earth in the future, which can be very dangerous. Scientists need to keep a close watch on near Earth asteroids to predict possible impacts and protect the planet. Another reason to study them is that actually asteroids are leftover pieces from when the solar system and planets like Earth were forming about 4.6 billion years ago. Studying them helps scientists understand how Earth formed and even how the building blocks of life, such as carbon and water, may have arrived here. Many asteroids are actually easier to reach than the Moon, which makes them great for exploration. Finally, asteroids have valuable resources like metals and water, which could be used to build space stations, make fuel, and support space missions in the future. June 30, 1908, a massive explosion occurred over a remote part of Siberia when an asteroid entered Earth's atmosphere and exploded in the air. Known as the Tunguska event, it flattened over 80 million trees across 830 square miles, but caused few human casualties due to the area's low population. Scientists believe the asteroid, about 130 feet wide, exploded about 6 miles above the ground, creating a powerful shockwave. This event is the reason we celebrate World Asteroid Day on June 30. On February 15, 2013, a meteor about the size of a 6-story building exploded in the sky over Chelyabinsk, Russia. The blast was super bright and the shockwave broke thousands of windows and injured around 1,200 people. Scientists later said the explosion was about 30 times stronger than the atomic bomb dropped on Hiroshima. The event was a wake-up call for space agencies around the world, showing that even small asteroids can cause serious damage. It also led to more efforts to track asteroids that could one day hit Earth. Chicxulub crater, located beneath the Yucatan Peninsula in Mexico, was created about 65 million years ago when a massive asteroid hit Earth. The impact released energy equal to millions of nuclear bombs, throwing huge amounts of dust, gas, and debris into the atmosphere. This caused dramatic climate changes, including a drop in temperatures and blocked sunlight, which disrupted photosynthesis and collapsed food chains. As a result, it led to the mass extinction of the dinosaurs and about 75% of all life on Earth. The Chicxulub impact is considered one of the most significant events in Earth's history, reshaping life on the planet. Between 1994 and 2013, small asteroids entered Earth's atmosphere and created fireballs 556 times, according to data released by NASA's Near-Earth Object Program. This means that small asteroid impacts happen fairly often, roughly once every 2 weeks, but they usually disintegrate in the atmosphere and don't cause any damage. These events are spread randomly around the globe. Now that we talk about famous asteroid events, let's talk a bit about what's being done. So NASA's Planetary Defense Coordination Office is a program established in 2016 to detect and monitor near-Earth objects, such as asteroids and comets that come close to Earth's orbit, and to protect the planet from potential impacts. So the Planetary Defense Coordination Office works with telescopes on Earth and in space, like NEOWISE and the upcoming NEO Surveyor, to track these objects and measure their size and path. If any asteroid poses a real risk of hitting Earth, the Planetary Defense Coordination Office alerts government agencies and coordinates response plans. It also supports research into asteroid deflection technologies like the DART mission. The Planetary Defense Coordination Office partners with international organizations to ensure global cooperation in planetary defense. DART mission, Double Asteroid Redirection Test, was a NASA project designed to test whether crashing a spacecraft into an asteroid could change its path, a method that might one day be used to protect Earth from a dangerous asteroid. Launched on November 23, 2021, DART targeted the double asteroid system called Didymos, which includes a larger asteroid and a smaller one named Dimorphos that orbits it. On September 26, 2022, the DART spacecraft deliberately crashed into Dimorphos to try to shorten its orbit around Didymos. The impact successfully reduced the orbit by 33 minutes, proving that the spacecraft can alter an asteroid's movement. Though this asteroid system poses no threat to Earth, it was chosen as a safe place to test this planetary defense method. Telescopes on Earth measured the changes in the orbit, while an Italian CubeSat named LiCube captured images of the event. This mission marks the first time humans have changed the motion of a celestial body and shows how we might deflect a real asteroid in the future if needed. Organizations like the European Space Agency, ESA, the United Nations, UN, and the B612 Foundation play key roles in global efforts to defend Earth from asteroid threats. ESA supports asteroid detection and leads missions like Hera, which will follow up on NASA's DART mission, by studying the asteroid Dimorphos after it was struck to test deflection strategies. The UN helps coordinate international response and policy through groups like the International Asteroid Warning Network, ION, and the Space Mission Planning Advisory Group, SMPAG. Meanwhile, the B612 Foundation is a non-profit focused on raising awareness, advancing technology, and supporting research to prevent asteroid impacts. Together, these groups help monitor, study, and plan defenses against potential dangerous near-Earth objects. Now that you know about the risk of asteroid impacts, there are simple ways you can help even if you're not a scientist. You can start by learning more and sharing that knowledge with others, which helps raise awareness. Follow missions like NASA's DART or ESA's ERA to understand how humanity is studying and preparing for asteroid threats, and watch documentaries or read articles to learn the basics. Share your new knowledge through social media, schools, or community events. Help dispel myths and panic when asteroid-related news come out. It's also important to advocate for science funding and to vote for representatives who support scientific research and space exploration. Some groups, like NASA's Citizen Science Program, invites people from all over the world to join real scientific research using just a phone or computer. Volunteers of all ages and backgrounds help NASA study Earth, space, and the universe by analyzing data, observing natural events, or even discovering new celestial objects. No formal training is needed, just curiosity and a willingness to contribute to science. Thank you so much for joining me on this podcast for World Asteroid Day. It was lovely to share this knowledge about asteroids and to learn together that they are more than just space rocks. They hold clues to our past, pose real risks, and offer future opportunities. From extinction events to cutting edge missions like DART, it's clear that asteroid science matters. Want to help? Stay informed, share what you've learned, and support space research.